Swishuri
presents Laser in Therapy by Javier Maccio. Introduction. Objective: to understand the operation of the laser from its basic concepts to its interaction in biological processes. Team: Javier Maccio, Design Consultant. Engineering: Mario Rivers, Doctor Sports Specialist specializing in laser and bioenergetics. Omar Ranchez, Doctor Honoris Causa Specialist in Biofrequency Physical Rehabilitation. From the acronym Light Amplification by Stimulated Emission of Radiation is a device that uses an effect from quantum mechanics, the induced or stimulated emission, to generate a coherent beam of light. Temporal coherence is related to the ability to concentrate the emission in a very narrow spectral range. Light. It is the part of the electromagnetic radiation that can be perceived by the human eye. It is composed of massless elementary particles called photons, whose properties, according to wave-particle duality, explain the characteristics of their physical behavior. Light. Physical effects: refraction, propagation and diffraction, interference, reflection and dispersion, polarization. Wave theory. Refraction. Refraction is the change in direction and speed that a wave experiences when passing from one medium to another with a different refractive index. Propagation and diffraction. In physics, diffraction is a characteristic phenomenon of waves that is based on their deviation when encountering an obstacle or passing through a slit. Interference. It is a phenomenon in which two or more waves merge to form a resultant wave of greater, lesser, or equal amplitude. Reflection. When a ray of light reaches the surface separating two different media, only a part penetrates into the second medium, and refracts because the speed of light is different in the two media. Consequently, two rays are generated, the reflected ray and the refracted or transmitted ray. Polarization. Electromagnetic polarization is a property of waves that can oscillate with more than one orientation. Wave theory. Consider that light is an electromagnetic wave, consisting of an electric field that varies over time, generating a magnetic field and vice versa. Since variable electric fields generate magnetic fields, Ampere's law, and variable magnetic fields generate electric fields, Faraday's law. Wave theory. In this way, the wave self-propagates indefinitely through space, with magnetic and electric fields continuously generating. These electromagnetic waves are sinusoidal, with the electric and magnetic fields perpendicular to each other and to the direction of propagation.
Quantum mechanics. Quantum mechanics is a branch of physics responsible for providing a fundamental description of nature on small spatial scales. Illustrative image of wave-particle duality, showing how the same phenomenon can be perceived in two different ways. Also known as wave-particle duality, it is a quantum phenomenon, well empirically proven, by which many particles can exhibit wave-like behaviors in some experiments while appearing as compact and localized particles in other experiments. Wave-particle duality. Currently, wave-particle duality is considered a concept of quantum mechanics according to which there are no fundamental differences between particles and waves. Particles can behave like waves and vice versa. Stephen Hawking, 2001. Laser. Light amplification by stimulated emission of radiation. It is a device used to concentrate light into a narrow beam, through which this concentrated and thin beam can be emitted coherently, with high efficiency in a very narrow bandwidth, which gives it the characteristic of monochromaticity. Characteristics. Bandwidth of light. The bandwidth of light is the range of frequencies that a light signal can occupy. It is crucial for the data transmission capacity in optical fibers. Wavelengths and color. Spatial coherence or directionality. Laser radiation has very small divergence, meaning it can be projected over long distances without the beam spreading or disseminating the same amount of energy over a larger area. Temporal coherence. Laser light is transmitted in a parallel manner in a single direction due to its nature of stimulated radiation, as the laser beam is composed of rays with the same phase, frequency, and amplitude. Elements of the laser. Optical cavity. An optical cavity or optical resonator is a device in which some light rays can remain confined thanks to mirrors on which they are reflected. These cavities are essential in lasers so that their light passes several times through their amplifying medium. The light reflected several times by the mirrors can interfere with itself. From this, it follows that only some wavelengths, and their associated waves, can be present in the cavity. Elements of a laser. Mechanisms of a laser. Spontaneous emission. Stimulated emission. Population inversion. Spontaneous emission. It is the process by which an atom, in an excited state, transitions to a lower energy state. As the principle of conservation of energy is upheld, the result is the emission of a photon. Spontaneous emission. In the figure, we can see the electron level jump and the generation of a photon. As these photons are reflected in the optical resonator, each one emits 2 photons, and so on. The diagram shows the effect of stimulated emission. Population inversion. The fact that stimulated emission produces 2 identical photons from an initial photon is precisely what allows the light to be amplified. It is also responsible for the light generated by stimulated emission being coherent, meaning that the electromagnetic waves forming the light beam are all in the same direction. Classification of lasers. Classification of lasers according to UNEEN 60825-1/A2-2002. Class 1, safe under reasonable conditions of use. Class 1M, like Class 1, but not safe when viewed through optical instruments such as magnifying glasses or binoculars. Class 2, visible lasers, 400 to 700 nanometers. Aversive reflexes protect the eye even when using optical instruments. Class 2M, like Class 2, but not safe when optical instruments are used. Class 3R, lasers whose direct vision is potentially dangerous but the risk is lower and require fewer manufacturing requirements and control measures than Class 3B. Class 3B, direct vision of the beam is always dangerous, while diffuse reflection is usually safe. Class 4, direct exposure of eyes and skin is always dangerous and diffuse reflection is usually also dangerous. They can cause fires and explosions. Symbols. Types of lasers. There are different types of lasers that fundamentally differ in the active medium where the emission is generated: gas, CO2 laser, Hene, etc. Solid, neodymium YAG, alexandrite, etc. Liquid, dyes. Semiconductors, diodes. Quantum dot, semiconductor that uses quantum dots as the active medium. Most used lasers in therapy. Diode laser. The diode laser is a highly efficient and compact light source, used in various medical applications due to its ability to emit specific wavelengths. It is commonly used in pain therapy, surgery, and dermatology. Diode laser. Therapeutic laser. On the left, we see a laser head used in medical rehabilitation, while on the right, there is a Swishuri MC400 type intelligent controller console. On the left, we see a laser scanner used in kinesiology and pain treatment, while on the right, there is a hybrid system model SP25 that combines 6 laser diodes with an audio frequency magnetic pulse system according to Dr. Rance's method. Low-level light therapy or photobiomodulation. The term LLLT, low-level laser therapy, has been modernized and is now more commonly known as photobiomodulation, PBM. This name better reflects the process by which low-power lasers or LEDs are used to stimulate and enhance cellular function. Effects. Biological effects, analgesia in the irradiated area. Anti-inflammatory. Antiedematous. Heals wounds and traumas in various tissues. Quantum effects. The quantum effect of laser therapy on biological tissues refers to how laser photons interact with the molecules and cells of the tissue. Here are some key points: absorption and scattering. Photothermal effects. Photochemical effects. Photoelectric effects. Photoacoustic effects. Main physical parameters, wavelength. It is the distance traveled by the wave in one period. It is represented by the symbol lambda, and its unit is the meter. The greater the number of cycles performed in 1 second, the shorter the distance traveled or wavelength. Main physical parameters, color and wavelength. Wave energy. It is calculated as the product of the frequency and Planck's constant, h equals 6.62 times 10 to the power of negative 34 J s. It is important to note that the energy of electromagnetic waves is quantized. Photon energy. The energy of a photon is proportional to the frequency of the radiation. It should not be confused with the luminosity or intensity of the radiation. The number of photons is proportional to the luminosity, but the energy of the photon is related to its color, wavelength. Power and energy. There are two types of laser emission, continuous and pulsed. In continuous emission, the laser is always emitting, and its power cannot be regulated. In pulsed emission, the laser emits at a certain frequency, where the pointer alternates between on and off several times per second. Power and energy. Pulsed emission. The power of a laser can be fixed but regulated using pulse width modulation, PWM, mechanisms, which control the duration of each pulse width. On the right, there is an oscilloscope measuring a laser driver. PWM modulation. Pulse width modulation, also known as PWM, is a technique in which the duty cycle of a periodic signal is modified to control the amount of energy delivered to a load. Modulation frequency. Modulation frequency refers to the number of pulses emitted per second. The diagram shows various duty cycle relationships for a pulse train of the same frequency. Wave energy. The shorter the wavelength, the higher the energy. For example, violet light has more energy than red light due to its shorter wavelength. Other sources of photons. LED diodes. LED, light-emitting diode. Type of light, emits visible, ultraviolet, or infrared light, depending on the semiconductor material. Efficiency, highly efficient, converting more electrical energy into light with less heat loss. The luminous efficiency can exceed 150 lumens per watt. Operation, they operate through electroluminescence. Electrons and holes recombine in the p-n junction of the semiconductor, emitting photons. Wavelengths, the wavelength, color, of the emitted light depends on the semiconductor material, GaN, gallium nitride, for blue and ultraviolet light, GaAs, gallium arsenide, for infrared. AlGaInP, aluminum gallium indium phosphide, for red, orange, and yellow light. LED light. Incoherence. LED light is incoherent, which means that the light waves are not in phase and have low temporal and spatial coherence. This results in a more dispersed beam. Bandwidth. LEDs emit light over a broader range of wavelengths around a central wavelength, with a wider line width compared to lasers. Dispersion. LEDs emit light in multiple directions, resulting in broader and less focused illumination. Quantum principle of an LED. Although both lasers and LEDs emit light through quantum processes, lasers utilize stimulated emission to generate coherent and highly directional light, while LEDs use spontaneous emission, producing incoherent and dispersed light. Each has specific applications based on these characteristics. Production quality. Caution with therapeutic devices sold on Chinese portals and similar. These often use low-quality diodes designed for home use and may not meet the necessary medical standards, resulting in reduced effectiveness and potential health risks. Thank you for staying with us until now. After exploring key concepts and parameters in the first part of our masterclass on laser therapy, we are pleased to announce the second part, which will address application details according to various specialties, as well as practical tips to facilitate the introduction to the fascinating world of laser therapy. Special thanks to our collaborators. We want to express our sincere gratitude to Dr. Mario Rivas, sports physician, with over 35 years of experience in laser rehabilitation and bioenergetics. His training in ancient Oriental techniques, as well as his academic and professional career in Uruguay, Germany, Cuba, and other countries, make him a fundamental pillar of our team. His dedication and wisdom have been essential for the development of this project. We want to express our sincere gratitude to Dr. Honoris Causa Omar Alberto Rances Ferretti, surgeon, specialist in physical medicine and rehabilitation, with an outstanding specialization in biofrequential therapies and international training. Of Argentine nationality, his national registration number is MN 131316 and his provincial registration number is MP 16939. His extensive experience and knowledge have been fundamental to the development of this project. His commitment and dedication continue to inspire and guide us in our work. Thank you. Copyright notice. All rights reserved. This video is protected by copyright. Its use is permitted exclusively for educational purposes, provided no part of the content is modified or altered. Reproduction in any other format or commercialization is prohibited without the express consent of the author. This video was created with Canva, and the background music is part of the files available in Canva Pro.